valleys. Here you see plains with little potholes in it. What you're seeing is that Pluto is a living world. It may have or have had, and amazing echoes. It may have had an ocean. And the idea of Pluto having an ocean is, wait a minute, this is way out there. How does it have an ocean? Well, it has an ocean because the ocean, or the stuff that has been flowing is probably nitrogen, maybe methane now. I wrote a short news story for Nature, and this was a draft that I was writing and wrote. This was the stuff I found before. Pluto is remarkably dynamic for an object that has spent 4 billion years in the deep freeze of the outer solar system. It's truly amazing how many different geological processes have operated, says Jeffrey Moore of NASA Ames. The surprise with Pluto is that it's so active, says Jay Malach of Purdue. Pluto's surface exhibits an astonishing array of landscapes, like Moore and 40 other members of the New Horizons science team wrote in a science paper. This is what you're seeing on these landscapes. I'm kind of reading this to remind myself of the details that are fun here. You're seeing the scars of 4 billion years of impacts. These things move around slowly out there, very slowly, but still they can run into each other and collide. So you've got some craters. You also can see no craters. They've got resolution of down to 390 meters, essentially 400 meters, on the surface, and there's this huge Sputnik planet, which is the heart shape on Pluto. And that's 1,000 kilometers wide, and there are essentially no craters on there. They're little potholes, a few little specks, potholes. Why? Because this is a dynamic system. This is a mixture of the volatility. What keeps Sputnik planet looking young is the volatility of nitrogen, carbon monoxide, and methane at the surface temperatures of 35 to 50 Kelvin. That's degrees centigrade above absolute zero. The gas is sublime and condensed under different conditions because Pluto moves from roughly Neptune's orbit out to about 70% further out, as I recall. So the temperature varies on the surface of Pluto. In the recent past was as close as it gets, and now it's moving further and further, and everything is going further out into the deep freeze.
Yeah, can I ask you to clarify one thing? When you say that's an ocean, does that cover the whole surface, or do we imagine it as being in parts of the surface?
Probably it would be underneath the surface.
The ocean you're talking about?
Yeah, this is underneath the surface. You have you have some heat, as you do on Enceladus, as you do on Io, and you do at some of the other icy fluids. You've got some heat down inside from the great big, probably at this stage mostly from the radioactive decay of potassium-40, I think, is the stuff that is most likely to decay in the core. And this heat is coming in, and it's melting a layer of water ice. Ice makes very good mountains.
So we're talking about layers. You have ice, and then you have a liquid layer. Okay, I just want to make sure I got this.
Yeah, no, that's fine. This is good.
It's weird, yeah, that is weird.
Reading these things, and I'm trying to pick out here some of the highlights. The nitrogen is the most volatile. The gases, let's see,
here is on the right.
but methane is most volatile, meaning it's most likely to evaporate. Methane is 1,000 times less volatile
but its ice is common and may be cold trapped in the Sputnik planet. So you get, you know, because it's not, doesn't get a lot of sun, which is 3-4 kilometers below the surrounding uplands. And a little lower down, it's a little colder. The details are not yet clear. I see that something has been going on for a long time and has completely modified the landscape, but I can't tell what made it this way, said one of the guys I spoke to. Some areas are almost primordial. The eastern part of Cthulhu Regio. Yes, Cthulhu. Named after an underwater monster god created by horror writer H.P. Lovecraft. I explained to the nature audience. Seems saturated with craters. They may date back to the late heavy bombardment that rearranged the solar system. And that was about 4 billion years ago. The water ice is bedrock. This is water freezes at 273 degrees Kelvin. Now, you're down more than 200 degrees colder than that. Water ice is rock, bedrock. Same thing on the outer moon, icy outer moons. There's also volatile-based glacial ice that contains about 90% nitrogen. It's soft, plastic, and can flow downhill. So you've got flowing glacier.
This is another layer.
This is a surface layer.
Oh,
And
okay.
what happens with the nitrogen is it cycles between the atmosphere and then it frosts out on the surface, and it makes this soft, volatile. Moore calls it silly putty on a geological time frame. It doesn't move very fast. Nothing moves very fast on Pluto. But you can see these things moving over geologic time, thousands of years. Or orbits. Orbits are 275 years or something like that, as I recall. Leads to some strange interactions. No one had thought soft, volatile ices might build water ice in the mountains several kilometers high. Think of something kind of vaguely like plate tectonics with ices in the deep freeze. When you lay out all these materials in a large sandbox, weird and wonderful things can happen, says Will Cutney. There's other strange terrains form at boundaries when you have these different cycles. So there's highlands near Sputnik Plain that have stretches of pits about 1 kilometer deep and a few to 25 kilometers wide, where glaciers seem to be running down troughs to the plain 3 to 4 kilometers below. So, you've got this huge evaporated lake or evaporated ocean. You've got stuff flowing down these hills on geologic time frames. Moore was surprised to find valley networks like he had seen on Mars and Titan, because he hadn't thought that nitrogen ice could be a working liquid, working fluid. In other words, you've got rivers of nitrogen, or soft flowing nitrogen. It's ice. It's sort of soft, not real hard as a glacier would be. Overall, and then Pluto's giant moon Charon has less variations in its surface structures and color. This is a moon that, as we know now, it looks as if Pluto had a giant impact early in its history, like the Earth did to form the moon. But with Pluto, what it had is one giant moon, Charon, which is not very far away from Pluto, and also is about half the diameter of Pluto. And then you have 4 other little small chunks of rock that orbit Pluto and resonances in the orbit. So you have there's like 2 and 3 and 4 and 5 or 6, I forget which, times Charon's orbit. there are these, in terms of how long it takes the moons to orbit, they're out there around orbiting Pluto.
Is Pluto tightly locked to Charon?
Yes,
I'm sorry, what was the question?
tidally locked.
Oh,
In
okay.
other words, it's tidally locked.
So that's not going to be a source of heat in Pluto?
I don't think, no, I don't think it would be. I think it's tidally locked. I have to go, this is stuff that I wrote a while ago, so I'm not always.
I got a question for you about that. When we look at this, is this something that's close enough to Earth and its moon, as you said it, that we actually are getting a better picture or more some verification of what we think happened to the Earth?
I suspect there is some similarity. I mean, what we're finding now with planets and, and the icy moons, we're finding that everything, by and large, is different. And there's different processes and different, it's not there was an assumption if you were studying planetary science 20 or 30 years ago that, oh, this is a very regular system we have around the sun. It's a nice regular pattern. There was Ohm's law, was it, that said, there was a certain relationship of the planetary orbits, and we expected this to be everywhere the same thing, all kinds of exoplanets, so that and there was quite a bit of doubt whether there would be exoplanets or not, how many there would be, but that was how we really expected all the other planetary systems to have the same basic layout.
The rocky planets and then the gas giants.
Gas giants, and then all these, and 30 years ago, what we thought was, well, there was one little odd snowball left in some comet in the form of Pluto, and then there were all these comets coming in from way out there that were small things, and now, starting about 20 years ago, we started finding, wait a minute, there's other things out here besides Pluto. There's a whole Kuiper belt of objects. And that's one of the other things that's where New Horizons is going now.
Let me ask you, you said Kuiper belt?
Kuiper, I think it's Kuiper belt.
Oh, Kuiper belt. All right, I know.
K-U-I-B-E-R.
K-U-I-B-E-R, yeah, I always said Kuiper, I was curious about the pronunciation.
Okay, no guarantees of my pronunciation.
All right.
Never met Mr. Kuiper.
So it's probably going to sound really weird, like someone's coughing up air balls.
All right.
Yeah,
There's a cherry brandy called De Kuipers, which is all the same stuff as I would
Kuiper.
Kuiper, oh, Kuiper.
Kuiper, okay.
Kuiper, all right. Go ahead.
All right, so we'll now see how many ways we can mispronounce. So, one of the features, there's some weird surface structures on Charon. One is Mordor Macula, a large reddish polar region, and for the benefit of the science, the nature readership, named after the dark lands of Tolkien's Lord of the Rings. Nothing like it has been seen on any of the icy satellites in the solar system. They think it might be volatile, so it throws out on this icy icy satellite. That somehow it throws out in the cold polar zone and remains long enough for sunlight to convert them to darker compounds that are too heavy to evaporate. So you've got there's another interesting process we have here. Methane absorption may be hiding evidence of ammonia on Pluto. Ammonia was something they expected to find. But New Horizons has detected it on Charon. So here is the moon, not quite the same composition as Pluto, even if some of the surface shares a common origin. Why? Well, this is another interesting fact. The general surface levels of methane are low, but they're higher in some craters with bright rays in their ejecta. So you've got bright rays, like on the moon. it may be that the sunlight and cosmic rays are destroying ammonia. So we've got, it may be left in there in Pluto's mantle. Remember, because you've got ices here that are behaving like rocks, all this layering instead of, the silica rocks we have under the Earth, under the surface of the Earth, are things like ammonia, methane, nitrogen, and water, which is probably the equivalent of granite on Pluto. So it's,
Is there a rocky core at any point?
I'm trying to see if they knew that, they figured that out yet. I don't remember. I think there is, but I'm not sure. There's so much to learn about Pluto that I haven't learned it all. I volunteered for this because when they were just doing the panels, because I said I was having so much fun writing this news story. They were looking for the panels, and I realized this is a lot. I mean, basically the lesson here is that Pluto is a world. Pluto is and with all the complexity we expect of a world, it has different geologic area places. Things differ over its surface. It may not be a particularly lively place hopping with life, but I mean, who knows what's going on in that if the ocean is still liquid. I'd have to go back and speculate and look at that, what they were talking about. There is some suggestion, Malaj has suggested that ammonia could be an antifreeze to keep water fluid. Ammonia is a pretty darn good antifreeze. And that would so you might have volcanoes on Pluto at some very weird time scale. This is, and Ralph Lorenz, who's a well-known specialist in the outer icy moon, says this is a magnificent reconnaissance. I expected Pluto to look just like Triton, but the haze layers, there's haze layers in the atmosphere, and there's a series of steps. If you look at the pictures of the atmosphere, there are layers in the atmosphere. Maybe layers where something is freezing out as you go higher in elevation. The iceberg mountains, they're essentially mountains that are icebergs floating in a sea of nitrogen. And there's what's called bladed terrain that I would have to look up to remember what exactly it is. But this is just incredibly rich and varied. And this is based on a day close to coming close through the planetary system of Pluto, looking at Pluto itself, looking at Charon, and I don't think they had as much Charon as they couldn't see all of Charon. They couldn't even see all of Pluto because some of it is in the dark. It's facing back, and Pluto doesn't rotate that fast that they can see a lot of it. So that's kind of a very quick tour of Pluto. And can I ask some more questions and see what I can...
We got all this information on just a few hours of observation, right?
And so, we're still getting data back. We'll have data back from a year, I think.
Yeah, I got it. Years ago, I guess it would have been sometime in the 90s, I was reading up on what we learned about the solar system. I came across a book, whose name I can't remember, but the author did an unusual thing. Most books on the solar system, they go by first Mercury, by the planets, Mercury, Venus, Instead, he arranged the book according to the different geological features of planets. You have a chapter on volcanoes, and the volcanoes of Mars and Earth and the moons of Jupiter have volcanoes. We're all there in one chapter, and it led to comparisons of the difference between them. And I felt it also was a neat way that increased my understanding of the processes on Earth. And to see if he's doing that for geologists, because we never before have been able to compare planets. You know, we just knew the volcanoes on Earth, but now we know what they're like on other planets, and we can make comparisons, and that helps us understand the process here. Have we, at this point, learned anything from Pluto that might fit into that?
Well, I think some of the, looking at the process of all the moons of Pluto. Now, there's been some work recently looking at Phobos and Deimos on Mars, and there are people now suggesting they are the last relics of a large impact on Mars late in Martian history that splattered material only up to a certain height, and most of it fell back onto Mars. So that Phobos, which is actually inside the zone of where moons can start breaking up, it's actually starting to crack. The Roche limit, it's starting to crack right now. That was something that I reported on last year from Science. It's starting to crack up right now. And now there's more coming out. There's, within a few million years, within maybe 30, but nobody really knows how long. Phobos is going to break up. It's, bits of it start raining down eventually on Pluto, on Mars. Now, interesting question. Why? This impact probably happened 4 billion years ago. Why? How has it managed to last this long? And that here we are seeing one of the last chunks, the last chunk that will go down, because Deimos is out beyond the Roche limit, so it's not going to crash onto Mars. So we may just come along at the right time to see the very last bit of that impact. So here we have 3 examples of different ways that large impacts have affected a planetary system. We have the Earth, we have Mars, we have Pluto. Each of them are in different areas. They're made of different materials, somewhat different materials. Earth and Mars are somewhat similar. So we're learning that. I mean, if you look at, and if you look at something like this, system of how you have icebergs floating on nitrogen seas, which are, I think they're sort of being rolled over because, if I remember right, that some of the methane is more fluid, that is lighter than the nitrogen. So you get all this, and ice, I guess, floats on it. So you've got all kinds of things, like what is the specific gravity, the density of these materials that make up your planet, and have separated in separate layers. And maybe you'll have icebergs floating on some planets, but the icebergs would sink on others because the materials are denser.
And you can understand the factors that lead to one result rather than the other.
Yeah.
Which means you better understand your own planet.
Yeah, and so we're learning things that, you have, and Solidus is telling us, you can have water volcanoes and salt water erupting out through the surface. I found here the research bolsters the case for a present-day subsurface ocean on Pluto. This was something that came out last month, which is why I was a little hazy on the recollection. That hadn't come out earlier, but they're saying there's Pluto might have, or now, or had at one time, in liquid oceans sliding around under its icy crust. They found that if Pluto's ocean had frozen into oblivion millions or billions of years ago, it would have caused the entire planet to shrink. But there's no signs of global contraction. So they think there's still something down there. In fact, New Horizons showed signs that Pluto has been expanding. I think it's some cracks in the surface. Thanks to the incredible data prepared by New Scientist, we observed tectonic features on Pluto's surface update our thermal evolution model with new data and infer that Pluto most likely has a subsurface ocean today. And this is, looking through at these surface cracks and patterns on Pluto. So again, here you've got different materials. I think the thing that is really, one of the things that's really going to be interesting to watch is what happens when the horizon gets to this other Kuiper Belt object that it's going to.
Well, that's right.
And I don't remember exactly what it is, but it's certainly not exactly a Pluto analog. I think it's something, one of these relatively small 100-kilometer order of magnitude objects that has some of the components of Pluto, but what components? How much rock? Is it differentiated? Pluto seems to be somewhat differentiated, but we really don't know. We're still figuring out how the Ceres is. They're kept the Dawn probe around Ceres, partly to save money, partly to figure out what on earth is going on there, because there's all kinds of layering structures in Ceres. That's another quote dwarf planet that looks like it's actually a world. And I don't fuss too much about what you call Pluto, whether it's a dwarf planet or a real planet. I think of Pluto as, what we're seeing now is a world. What you're seeing, when I was a kid, Pluto was a little dot. We didn't even see Pluto, we didn't even see, we kind of saw Charon as a bump out of it first. And then they fixed Hubble. And you could see, here's Pluto and here's Charon. You could see them as separate things. And now we've got, as Hubble was looking at it later, and I think as they were coming closer, they were worried about other things besides the five moons that they know now. There might be other things that they might have a mini asteroid belt around Pluto that could crush the horizons, but there wasn't anything. But they spent time looking on the way. So it's really been a fantastic.
The one question that always comes up, of course, is people interested in the search for life. I got a notion that you said methane, right?
Well, I would think what it probably is some combination of ammonia and water.
Oh, okay.
Or
So
ammonia.
you got water.
You've got water, you've got ammonia.
All right.
It's something that, and
Do you have enough heat to produce life? That's, I'm just, is this just like we talk about it on some of what's the some of the type, yeah.
Titan has water under its icy shell. It also has lakes, but they're made of methane,
Which is a building block.
which is a building block. Or why do we have to have water-based life? Maybe we have water that's something that's living in an ammonia ocean, or an ocean of ammonia and methane, or a nitrogen ocean. Diluted. I'm not. I think one of the things we should realize is, unless I'll be talking some about exoplanets, because I've also been writing about exoplanets. I think one of the things we have to learn from all that we're learning now in the last 10 to 15 years about planets in our solar system and others is that they are tremendously varied. There's a far wider variation than we see in our own system. There's things in between. There's a whole class of super-Earths that are somewhere between Earth and Neptune. I mean, we think of Earth and Neptune as very, very different things, but what is an Earth is something, Neptune is 10 Earths or 50 Earths or something like that. It's not, it's part way between, it's an ice giant because of where it is. We don't really know all of what's inside. Probably some kind of core there. They think there's a core we've accreted there, but is this a super Earth? And when you find some of these planets are in entirely different positions in other solar systems. So I think when we find life, and we may not find life everywhere, but where something can evolve that sustains itself and replicates itself. And that may be something very simple and may be powered by solar energy, even out on Neptune. Maybe not. I don't know. These are ideas to play with what you can see.
Anything else as a question?
Just coming on from that last point, you said 273-year very elliptical orbit with 70% sweep. Are the conditions now sufficiently different from how it would be at perigee or apogee for us to be able to draw on the first conclusions?
Well, let's see.
Okay, as I understand it, it's whether point in the orbit, whether it's closer or further, whether current conditions would be different, but it's, where is it now, is the closest to the furthest?
It's fairly close.
Fairly close. It was,
Okay.
I think, about
Sorry.
1990 or so that it was closest.
All right, so will it be different when it's further?
And I think, there was concern as they started the New Horizons mission. They wanted to get there before the atmosphere froze. That was one of the real, because once you get out, and I think it goes out about a fact about 75% or so. I'm not sure of the eccentricity, but let's say that's enough for the solar energy to be declined by a factor. Solar energy, so probably a factor of 2 or so. So that the temperature will drop further. So that maybe you freeze the nitrogen out, or maybe. Oh, good, yeah.
Okay, the thing is, what they've seen on the surface is signs of expansion, which suggests that there's an undersea ocean which is full of water, which is slowly freezing. Ice expands when it freezes. However, if it had frozen solid and things continued to cool down, the ice would have then changed phase to ice 2, which is denser, smaller. So we would also see contraction markings on the surface. We don't see any contraction markings. This means that maybe there is a water ocean under there which is slowly freezing, but it did freeze solid a long time ago. So it may still be liquid. They're going to keep flow calculations, and this is what that suggests, that there may very well still be a liquid ocean underneath the surface. And 275 years is much too short a period for the magnitude difference that deep down underneath. It makes a difference on the surface of the atmosphere, but not for an ocean that's 30, 50 miles down.
Yeah, thanks. That's a good help. And that, you may see some, this is maybe why you see some of the flow patterns on the surface, that when you get closer, it gets a little softer. But, it would flow very slowly. It wouldn't be all flows down into the lowlands. And you may have some of it evaporate and then condense out when it gets out to the far extent of its orbit.
But as he said, when you get down deep, it's not going to make much difference.
Yeah, the main function would probably, main heat thermal effect at that distance is probably from the, whatever is in the radioactives or in the core.
That was a great question and a great answer. Thank you both.
Yeah.
Question?
I know that there are standards and systems for naming features.
Yeah.
I learned from Jeopardy the other day that features I need is now named after women. So there's a Margaret Mead prayer. So we've got somebody put about Cthulhu and Mordor and Sputnik. What's the system for South Africa?
That's an interesting question. I think there's some things relating to the underworld, Cthulhu and Mordor, and outer reaches of darkness. That's what Cthulhu and Mordor sound like to me. I haven't really looked into what they are, but they are. I mean, clearly they're having fun doing this, and I think that's important because it makes it much more interesting to have these weird names out there.
Sputnik is the only one that doesn't fit the patterns. Maybe they just felt something on the name Sputnik.
I think it's, I don't remember what they call it. There is some Russian part. Maybe somebody who understands what's not means in Russian.
I believe it means fellow traveler.
Yeah, fellow traveler.
Okay.
Or companion, wasn't that one of the other terms given?
spotted and identified the, from the Hubble telescope photos.
Oh, okay.
And so that was pretty busy day. Now, it's just this very, very vague light blob, very, very vague dark blob.
Okay.
Tiny, but they can name it.
Oh, okay.
Yeah.
Any other questions?
I would imagine with the stuff they found so far, it's whetted everybody's appetite to go put an order around the thing. I would imagine it would take a special time to plan, design, fund, launch such a thing until you wait for it to get orders going. That any of us in this room probably won't survive long enough to see it, find out what the results are. But, is there cooperative plans, this kind of thing, if it did arise, how many